This is question 1d. The question asks us whether a finite sequence have a pole and where it is ROC. The answer is finite sequence does not have pole, or I should say the pole is only at the origin. Let's try a finite sequence xn. So the sequence only have 3 values, 1, 2 and 3, with the rest of the values 0. The z transform of this is 1 plus 2z minus 1 plus 3z minus 2. That's all. Now, where are the poles and 0? To understand that, we multiply top and bottom by z squared to make the xz into positive powers of z. So we have z squared plus 2z plus 3. And we have z squared at the denominator of this xz. So when z is equals to 0, this value will be 0, and therefore numerator divided by 0 will be equals to infinity. So when z equals to 0, this goes to infinity, implying z equals to 0 is a pole. So we should draw a pole here, and then we want to put 2 because there are 2 poles because of z squared. The region of convergence is only interested in the pole location. If it's a causal sequence, we look at the pole and then we start to shade outside the pole position in a ring, in a circle. So we can now shade the entire surface of the z plane. So this is the causal finite sequence. What about the anti-causal finite sequence? So now I change the sequence and I put the arrow here. So when I have x of z, so this is equals to x of n. So we now have n equals to minus 1 to minus 3 because the rest of the values are zeros. So therefore, we now have x of minus 1 times z of 1 plus x of minus 2 times z of 2 plus x of minus 3 times z of 3. And this is 3z plus 2z plus 1z cubed. So this is the answer of x of z. Now, since we have x of z equals to 3z plus 2z squared plus z cubed, there is no pole. There is only 0. So the region of convergence is the entire z plane, except, of course, when z is at infinity. When z is at infinity, then x of z will not converge. So the ROC is all of the complex plane except z equals to infinity for a finite anti-causal sequence. So it's finite anti-causal. Right, I think that's all we have. Thank you.